Hello, everybody. Welcome to the Mindplex podcast. I'm Lisa Ryan, and I'm here today with Matteo Borri. Hello, Matteo. Say hello.
How's it going?
and Matteo is an inventor, a roboticist. He does 3D printing, does laser cutting, makes lasers, um, works with NASA, and invented a prototype design that was implemented on the Mars Perseverance Rover, and is very up on space and all these kinds of things. And there's so much going on in space right now that I asked him to just come on and go over it all with us a little bit. So the first thing we're going to talk about is this moon landing. And yeah, so Matteo, tell us what you think is interesting about that.
Well, what's interesting to me is I am a roboticist, I'm an engineer, and the Odysseus lander, which is the first lunar lander in quite a while that works perfectly. You may have seen that a couple of weeks ago there was a Japanese lander. It did the landing maneuver perfectly, and then it flipped itself upside down at the very end for some reason. We're still trying to figure out why it did that. Sounds like somebody's been playing Kerbal Space Program a bit too hard. Odysseus, which landed yesterday, is essentially an engineering demo. It's a commercial system. It was carrying both NASA payloads and corporate payloads, and it was mostly a dress rehearsal for a larger lander because it doesn't actually have that many experiments on itself. The ones that are there are related to being able to find it very precisely, and it did have something unusual for a craft that size, which is it had redundant imaging systems because it's one of the things that they wanted to test. This actually proved very important because the main landing camera decided to take a nap about in the last 5 minutes of the landing. So the backup camera had to take over. It was put there as a way to test it, and it ended up having to do the mission by itself, essentially. Now, note that this is possible because the moon is only about one light second away from Earth. So it is possible for somebody on the ground on Earth with a radio control, like imagine like an old-timey RC plane control. It is possible in a pinch to fly a lander that way. I think the Russians did it in way back when. But the important thing is that if you send a correction command, like switch to the other radar, it will arrive in a second. For a Mars lander, we can't do that because the light speed lag is greater than the reentry window. So any command you send would be too late.
Okay. So for this mission, what did they do?
For this mission, they led the thing experiment. There was a mix-up in the last five minutes, and what happened is that the landing camera, which is on the bottom of the craft, it didn't stop responding as so much as it stopped processing images correctly. So this thing is pretty small. There's not a lot of room for a proper radar or anything else. So it had to go with what it could see. Remember, there's no GPS on the moon. This is actually one of the things that Odysseus wants to do is that they want to set up a local positioning system, and it's gonna act as one of the antennas for it. But let's go back to the landing for a second. So this thing is coming
Okay.
down, and its camera acts up. Let's say it's trying to land on my shoulder. The camera acts up. So what they did is that they switched to the other multi-lens camera that's supposed to give you a 3D picture for just one camera. I think that shows in the pictures, and they used that as a rangefinder to be able to touch down softly. Uh,
Okay.
Again,
So there's,
Odysseus
go
is
ahead.
primarily an engineering demonstrator, so that means that they put a bunch of stuff on it to test to use on a larger lander later. It also has a couple of little experiments. It has a couple of things that people wanted to send on the moon. There was a company that took a essentially a USB drive to leave it there on the moon to say, hey, this data is now archived forever because nobody's gonna mess with it except the next guy with the next lander. But
Yeah, or anybody with a magnet. wants to fly by the moon with a magnet, right?
Take
At
a
least
trip.
put 2 of them. At least put 2 of them up there. Have a backup
Yep.
or something. Yeah.
No, no,
What's
that's
the other
okay.
experiment that one of the other experiments that it came to do up there?
There's a couple of simple experiments on it. There's a retroreflector, which is the first new retroreflector on the moon in a fair amount of time, I believe. What that does is that it's a very precisely aligned system of lenses and crystals. And if you shoot a laser beam at it, it will always send back the beam in your direction exactly at 180 degrees. And this is good enough that we could make these things 50 years ago in the 60s, and we did. And the
Mhm.
Apollo astronauts left some on the moon. Since this is a passive instrument, it's been working for 50 years. And we've been using it to determine, when you read, hey, the moon is getting away from us at 3 inches a year or something like that, right?
Mhm. That's how we know?
And that's how we know. We shoot a laser there, it bounces back, and again, light has this nice thing that it also always goes at the same speed. So you get exactly
Yeah, so we can
the distance.
triangulate its exact distance, that thing still works.
Yeah.
That's amazing.
So Odysseus had one of those, so that's another spot on the moon that we can shoot a laser at to check where it's at. And it also had, again, mostly a bunch of redundant cameras and various types of cameras. It's got a gas detector on it. The commercial payloads are not super interesting to me. There's a clothing company that wanted to have some piece of cloth on the moon for promotional reasons, I suppose.
Okay.
And then there was this data vault, guys, which is more interesting, except, you can't get to the data. What they want to do is that they want to actually put a data center on the moon that can be accessed via a radio link. And the idea is that you put stuff there that you would not back up any less safely. I think it's a case of safe storage more than secure storage.
I think it sounds
The
good to say, "Oh, my shit's backed up on the moon," right? As if it was
Pretty
somehow
fair to
better.
that aspect. Yeah, that's
Yeah.
fair.
Go on.
That's it. That's really
Oh,
it.
that's it? That's it about
The,
well, let's
Odysseus-
talk
the,
You've said a lot. Let's talk about this. So there's no GPS on the moon, which is an interesting concept because the GPS is based on the Earth. So we basically
GPS satellites go around the Earth. The
Uh-huh.
problem is that it's very difficult to get a satellite in a stable orbit around Earth's moon because the moon's center of gravity, it's a little off compared to where it's spinning. There's all these regions of lower, higher gravity. We think that it's because there's this big molten slabs of iron or nickel underneath. And as a result, the moon's gravitational field is pretty lumpy. What that means is that it is difficult to put a satellite around it because this satellite will eventually get perturbed. It will get tidal forces from the Earth. It will get a lot of noise. And in a few years, no matter how good the orbit was initially, it will either bump into the moon or just be thrown out into the wider solar system. So every time you see a satellite put around the moon, they know that it's going to stay there for 1, 2, 3 years at the most. Unfortunately, that makes making a GPS system for the moon very impractical because you would have to keep launching satellites. That gets expensive. So what they want to do instead is that they want to set up a local positioning system akin to what you used to have for ships before GPS. It was called LORAN. And like GPS, it's something that the US Navy came up with, except for the first version. I think it was a UK thing. And what that does is that it works like the location that you get on your phone with GPS off. So you've got all these signal towers at positions that you know where they are. They send their little radio signal, and unless you're smack in the middle of a crater, you can't see the edge. You should be able to pick up that signal, and if you pick up more than two, you can triangulate yourself and see where you are. This is not going to be as precise as GPS because Lauren wasn't, but it will be easier to implement because you're just gonna land something, it's just gonna stay on the ground. Like I said, you cannot generate a stable orbit around the moon without using propellant, which means your satellites have a finite life there.
Wow. Okay, and one of our viewers is saying, "Hey, that's really interesting. So we'd have to use towers or a reusable craft that acts as a satellite."
Uh, the current plan is to use towers, and Odysseus is basically a scale model. One of these towers is just going to send out the navigation ping, and that's one of the things that they want to test. Again, Odysseus is less of a science experiment than an engineering experiment. They're testing out things that they already know the principle of, but we want to make sure that they work. We want to make sure that they work well. We want to make sure that they work reliably. And the idea is that it's a prototype for various things that the more specialized landers will do later on. I have to point out that I'm not involved into this. When I say we, I mean kind of the human race. I'm a
Yeah,
bit,
yeah.
old-fashioned cosmist in that end.
Yes, as am I. That way, I often say "we" too when I'm talking about the human race, which is a good thing to think about. It's us, and we really need to think about how we're going to be interacting with aliens and treating them respectfully too. If we could learn how to treat each other with respect, we would be off to a good start, like the Rocinante did. So, so going on with this idea of testing out engineering principles on this mission, I know that NASA actually funded the mission, or partly. Did NASA have any other experiments that you know of that it's going to, you know, have conducted while they're there?
On the Odysseus, I think that they mostly had that the second camera, which they ended up using as a primary because the primary kind of had a seizure at some point, and then they have the retroreflector, and that's really it. Like I said, it's an engineering test. The main experiment there was, can we auto land this thing? The result was not quite. We had to tell it to switch cameras. However, the camera switching systems worked. Ability to just the ability to process the data worked. So I guess what they're gonna do from now on, if I know the engineering standards over there, they're gonna say, okay, next time we make a moon lander, we're just gonna put two cameras underneath and be prepared to switch over. Another thing that was there was a simple spectral analyzer that studied the plume of the landing rocket. Like, think back those old lunar lander video games. You just got this plume hitting here. And what they wanted to do is that they wanted to take very careful pictures of the plume in various spectra, so IR, UV, visible, because that allows you to make some inferences about lunar dust. Now, lunar dust is very interesting stuff because it's very spiky. It's never been subjected to air erosion because there's no air. Very interesting for its physical properties. Interesting for its chemical properties because obviously we're looking for stuff on the moon. We're looking for helium-3. We're looking for oxygen. We're looking possibly for carbon because finding quote unquote primordial carbon that has never been in a living being would be very interesting. But
Hmm.
the main thing here is you're gonna with this little lander you're gonna see what it does so that you can build specialized landers for later. The other reason is that this was a feasibility test. Can we cut down on costs? Can we make this thing as small as possible? Can we get some sponsorships? This was an engineering test, even for the fundraising and economics part. And what they found is that yes, this is pretty much the smallest lander you can get that will work properly. And again, they're probably gonna standardize on putting two cameras on it for landing.
Okay, great. And
Um,
then this piece right here that saved the day should be sharing, right?
yep.
This piece right here that saved the day. Tell us a little bit about that, how that was used, and how it was basically taken apart. It was parts of it that were used, if I understand correctly. Tell us about it.
Yeah, nobody took it apart. This is
Oh.
sorry to disappoint. This is not
Oh,
Apollo
okay.
13. What happens is that this thing here, which is if you look at it, it's probably a 3D camera of some sort. You got this fisheye lenses, so it's probably either a 3D camera or like a 180-degree dome camera. Just by looking at it, you don't have to have looked this stuff up. It was stuck on the outside of the craft. It's not integrated into the craft. It's a science payload. It's an engineering payload in this case. And what happens is that what this will do is that it will try to get a picture converted into a point cloud and actually get 3D information without having two cameras at two different places. And what happened is that when the main instrument that's supposed to do a simpler version of this job for the purpose of landing, just imagine like a sonar rangefinder, except you can't use sonar on the moon, obviously. They switched to this thing to be able to say, okay, we're this close, we're this close, we're this close. And they basically had to use visual information to land, like in that old lunar lander game.
Okay. So that's where they were lucky they had. So what I'm hearing is backups. It's all about backups, backup cameras, backup
Yep,
equipment, backup
yep.
plans, backup. And it's funny, the
And
one
apparently,
time, yeah, go ahead.
apparently, some guy, one of the sponsored payloads for Odysseus again was somebody's backups, so that fits, I suppose.
Even the guy that went.
Well, one of the commercial payloads on Odysseus, like I said,
Oh,
it's from a data recovery company that said we're gonna put your data on the moon. So I guess somebody's hard drive
oh,
was
so it's
backed
a
up on the moon.
backup. It
There you go.
really is a backup on the moon. Okay, cool. So let's talk about some of these other ideas that other things that made this very unique that the news wasn't really talking about at all that I wanted to get to the bottom of with you. But we were talking about it a little last night because I was trying to understand. So this is not only is this the first US moon landing in 50 years, and the first commercial moon landing ever, but it's the first time that liquid methane and liquid oxygen have been used for a lunar landing rocket motor, which you pointed out was interesting because those are all gases, liquid methane and liquid oxygen, that are easy to make with an automated factory.
That's
And
correct.
and
So
I
this
was
is
like, "Oh, okay. Why is that exciting? Let us to tell us."
well because so this is more of a Mars thing because there's no carbon on the moon.
Uh-huh.
We would have to import it somehow.
Okay.
Um, but methane and oxygen are relatively easy to say. Again, let's the device was tested on the moon, but let's pretend that it was on Mars. What happens? You land your little rocket, and then it starts crunching through the Martian ice it has around itself. It starts sifting through the atmosphere. This is actually one of the really cool things about the Perseverance rover. We have done this thing that I just said with oxygen. Not a lot of it. We got maybe half a liter of oxygen in a year. But the point was to prove the principle. It's a simple machine. It can be carried on a rover. It's resilient enough to work for a year without maintenance. And what you get that way? You get fairly simple gases. You get hydrogen, you get oxygen, you can get methane, which is CH4. And what's interesting about this is that you land little your little base. It doesn't even have to be a rover. It starts harvesting the atmosphere. Maybe you can even use some of that water ice if you can get to it. And very slowly builds up a store of oxygen and a store of propellant, which in this case is methane. And let's say that this thing has a sample return rocket. Now you can fuel that sample return rocket with the propellant and oxygen that you did not have to bring from Earth. So you saved yourself a bunch of launch mass.
Aha. Okay.
And besides, if we're going to the moon or to Mars, it's well and good to just put something there and then you have to keep resupplying it, which is what they do at first, obviously. But eventually you're going to have to homestead. You're going to have to use the local resources. The good thing about doing it on another planet is that there's no life to mess with and there's no native population to kick out and then feel bad about it 200 years later.
Well, we hope there's nobody there, right? I mean, you and I actually talk about this a lot in terms of
Well, there is,
planetary protection, but
yeah,
on the moon, we're pretty sure there's nothing there.
on the moon
And
we're
on
very sure,
Yeah,
and on Mars we're at this point we're hoping to find traces of past life. I
right.
don't want to say that we've given up on finding present life because if that happened, there would be a lot of celebration in a lot of places. But right now, what we're doing is looking for evidence of past life on Mars. On the moon, what would be interesting, like I said earlier, would be to find the carbon, so carbon atoms that have never been in a living being, because you can't have anything alive on the moon realistically. It would be interesting to, if we found carbon on the moon, it would be, first off, it would be interesting to figure out how it got there. There's many theories on how the moon came to be. It was aggregation, it was a collision with something else. And then we could compare it with the carbon that we got here that gets in and out of living organisms constantly. It should be the same stuff, but it may not be.
Because carbon's carbon, except when it's not.
Carbon is carbon is carbon, except maybe it's not. That's why you go. That's why you send robots around to do your testing, and then you follow them.
Right, right. And water, so basically fuel and water is what we wanna be able to make there, whether it's the moon
Yes,
or
everything
Mars,
else comes from that. Everything else comes from that.
because until we can do that, it's basically unfeasible to try to have people living there.
Is Yes, exactly. It's feasible to have people go there and come back like they did with Apollo,
Yeah,
but it will not be feasible to have people stay there for the long run unless they can at least partially homestead and live off the land. And
right.
that's true in pretty much any environment.
Sure, sure, and then there's bigger problems in terms of, you know, isolation and, if you're on Mars with no environment for breathing, you'd probably have an area unless you were in your suit, you'd have to be inside, right? Like in the movies, right? Like, you'd have to be in the
Yeah,
station, right? Kinda thing.
yeah.
But being able to make water has all these interesting, implications. You mentioned earlier there's no sonar on the moon, of course, but I don't
Yeah.
really understand what the "of course" is. Explain that to us.
Well, sonar works by sending out a pulse. Usually, it's for sonar rangefinders like you may have in your car. It's usually 40 kilohertz, so you don't hear it. For the record, dogs do. To them, it sounds like somebody's clicking their tongue. And you send the pulse out. It bounces on various things that are in front of your little speakers, and it comes back. Then you hear it. You generally take the first echo. You do a little bit of signal processing, and it tells you how far you are from the other car. This process is very simple to implement. You were able to buy a consumer sonar rangefinder 20 years ago. The math is well understood. You can even make one that self-calibrates using temperature if you need precision. And that's just something that we have in our toolkit. You use it, it's used in cars, it's used in factories, it's used in all sorts of things. But
Mhm.
that requires an atmosphere. In particular, that requires an atmosphere that is somewhat dense. Of course, you can also use it underwater. That's what submarines do. But that's even better because if you think about it from a certain point of view, an ocean is just a very dense atmosphere. It's dense enough that it just collapsed and became liquid. So you
Right.
can do this on Earth. You can probably use a sonar on Mars. There is very little atmospheric pressure, but it is enough to fly a helicopter. So you can probably use it for a sonar as well. You got better options, but so you don't need to, but you could in theory. On the moon, you can't do any of this because there's simply no atmosphere. Well, one of the things that happens on the moon is that you've got this tiny, tiny bit of atmosphere. It could be maybe 20 tons for the whole moon. It's mostly hydrogen and helium. And what happens is that which, depending on the angle that the sun is striking this or that piece of the lunar surface, it outgasses a little bit of hydrogen and helium. And one of the things we have to figure out is how is this stuff being produced? Is there some nuclear material on the moon that decays and occasionally lets out a proton, occasionally lets out an alpha particle, and they just kind of percolate up? Was it there? Was it there from the start? We don't know yet. Again, this is why we dig.
Yes. Why we dig. So you mentioned, let's see, I'm trying to think if there's anything else about the moon landing that you think is interesting that we haven't talked about yet that probably other people aren't talking about.
I think it's very it's very interesting that it got done. And it's also interesting how close to optimal this design was. They set off to say, let's make the smallest usable lunar lander, and they got very close to the theoretical minimum. Uh, Perhaps a little bit too close. Again, next version is probably going to have two landing cameras, but overall, it's a very interesting feat of engineering, even though we're not using it to do any properly basic science. That will come later. The other
All
thing that's
right.
interesting is that it. The other thing that's interesting is that it shows that the hybrid approach to paying for the damn thing is feasible. That was actually a concern at NASA because they, you know, they have a mandate to fight bureaucratic bloat within their own organization because they all do, and they're actually making an effort. So what they try to do here is that they try the lean and mean approach and say, okay, different company, which is Infinity, make it a lander. You got control. We're just gonna add this or that payload on it. In this case, it so happens that one of the payloads ended up also doing double duty.
Exactly. Saving the day. So, all right for gotta love those NASA payloads. All right, great. Well, thank you so much. I knew there was a lot more to that than was being discussed in terms of the future implications, which is why I love learning from you about things that are happening in the news because there'll be some story that's being propagated on all the channels, but when I talk to you about it, there's usually something much more interesting and important in terms of what it means for the future going on. And so that's why it's so great to get your take on this stuff. So we're going to go, you talked about before in terms of looking for past life, and that's a perfect segue into our next subject, which is the lakes that they found. um, and it's funny because I interviewed you about lakes on Mars back in 2018 when we had gotten some information that made it look like there were pretty much lakes on Mars, but were always clear to say that it hadn't been definitively proven yet. And so what has actually happened is that it has finally been definitively proven, and I'm going to go ahead and go to where I've got these pictures about this lake. So right here, okay, so here's the basin. This is the crater where they found the lake.
Well,
And yeah,
this is where they landed the Perseverance rover,
okay.
and they landed it there because they wanted to have an easy time to see whether that was used to be a lake or not. And at this point, we've gone from possibly to extremely likely. I point out, though, that the first evidence of a planet-wide groundwater system is actually from orbit. It came from the ESA satellite that's been surveying the planet for a few years now, and they said
Uh-huh.
we believe that there may be something like a frozen ocean under a significant amount of rock, and the only way we can test that is gravimetrically and seismically, which they eventually did, but it took 4 years because for some of these things you do when you can. So what they
Okay.
found is not only Jezero Crater was, for some of its existence, a lake, but there is also a substantial amount of ice under the surface. It has been described as an underground ocean. This is not correct. It's more like think about mineral veins, but not the ones you see in real life. The ones you see in video games, they're all shiny and they kind of pervade the rock, like tree roots. Imagine something like that, but with ice in it. Now that's
So,
interesting because if we can figure out where that is, we can drill to it, and we're talking about extreme quantities of
mhm,
H2O here for the average individual. Even a little bit of water on Mars, if you're only trying to get to keep, even let's say 1,000 people alive with it, is going to
mhm.
last for certainly longer than oil will last on Earth at this rate.
So I'm looking
That's why
at the
it's a big,
3. Yeah, yeah, it's a big deal. So I'm looking at the 3D, um, the sample that we have here, and basically this is as if you were cutting through the surface of the planet, basically, to get down to
yeah. So
where.
this is a big, yeah. This is not actual test data. This is a representation to show what we're talking about.
Ah, okay. I didn't realize that. Okay, so that's representation. Now this you were telling me is showing it's a grab from Earth of the Earth sort of a river delta system and then
Yes.
comparing it to Mars. Could you tell us some more about this?
Well, so this is a river delta. It's pretty standard. You can see the water, you can see the mud, you can see the kind of fractal broccoli-like disposition of the little effluents. I love these pictures. They're just pretty. And
Yes.
on the left, you can see the a similar formation. You can kind of tell. I suggest looking at the kind of cyan parts right in the middle, a little bit further down from the very middle. You can see the same kind of formation, indicating that there was some fluid that has flowed there to generate this kind of shapes in the in the I
Yes.
guess you could call it soil at this point, in the sand that would be remaining. And that's a strong indication that there was a liquid there flowing. Now, what we don't know, we are at this point we are thinking that it's water. We are more and more sure. But just 30 years ago, when you started getting the first images like this, we didn't know if it was water, if it was just very fine sand that then turned into sandstone over the millions of years. We didn't know what liquid it was. Now we are very sure, but not absolutely sure that it is water, meaning there was more water on Mars than we thought, meaning there is still a bit more water than it looks like. So that makes it worthwhile to figure out where it is and say, okay, let's try to land here and let's have like a water derrick and pump it up.
Yeah. All right. And the point, and we're looking for fossil bacteria
Yes,
in these
because
riverbeds. Tell us more about that.
well, eventually what we're gonna do is that we're gonna build some kind of a derrick. We're gonna pull up some of that ice. Now that ice has been there for a long time. Given that it's a bunch of ice, which seems to be mostly continuous, it's not just water impregnating some granite, for example. It probably dates to a point where you actually did have some kind of a large lake or a sea on the surface of liquid water, because it wouldn't have this thing would not have formed otherwise. At this point, if there is any evidence of ancient Martian life, could be fossil bacteria, could be maybe if we're very lucky, something like eukaryotic cells. At the very minimum, if we find ice, it will be dirty, and we can see the dirtiness of it. If there's RNA molecules in it that have been left there, we could see if there's any kind of organic chemistry that ever went on. So that makes it both a useful resource because, again, it's water. You can separate it into hydrogen and oxygen. You can breathe the oxygen. You can burn it again to get some trust. It's both an useful resource, and there is a legitimate reason to pull it out of the Martian ground rather than bringing it over, other than it's cheaper to pull it up. Because as you process it, some of it will inevitably be kept and studied, and then we can see again if maybe we get lucky, we find fossil bacteria. Maybe we get a bit of limestone with those little indents that show that there was some multicellular life on it. Maybe we don't get very lucky, but we find some nucleotides, and they're different than the ones that you find on comets, for example, meaning that they have undergone some amount of evolution while they were there. At this point, I don't want to sound pessimistic, but it's safe to say that we have, and again, I say we in the general sense, make it, I want to make it clear that we have switched from looking for existing life to looking for past life. That doesn't mean we've given up on looking for existing life, of course, but it does mean that we consider it more likely. The beauty of this kind of effort is that you're never sure. You could find something tomorrow that forces you to re-examine everything because it's the point you were now counting on. Unfortunately, most of the science that gets done for this stuff is the quote unquote boring kind. Some people think it's boring because it's not a new revelation every 2 weeks. But what we have been doing is becoming more and more confident on certain things. For example, there's not only there's water on Mars, there's more than we thought. What's interesting is that this was actually not found by the rover. It was actually found by a satellite in orbit.
The water. I mean the ice.
Well,
What was
evident.
not found by the rover exactly?
Well, the rover can't really drill that
Right.
deep. We're gonna have to send a specialized machine that is gonna look a lot like an oil derrick, except it's gonna have to be self-assembling. But what the satellites have done looking at Mars is that they compare their readings with the first ones they made even 20 years ago,
Right.
and that gets you a baseline for a lot of stuff. For example, if the satellite finds that its own orbit is slightly disrupted, it means that it's going over some areas where there's more metal near the surface, or there's more light material near the surface, and that's about it.
So, let's talk about that system for bringing a sample back because we talked about that a little bit before, and you mentioned that it's actually uses kind of like a slingshot mechanism of sorts to get it out of the orbit before it gets the way back home, and it's actually sort of like pseudo BattleBot technology from yesteryear. So, explain that to us a bit. Oh, you're muted. Just a second.
Yeah,
There you go. Carry on.
sure. So if you're talking about the sample return mission, this is the next quote unquote big Mars mission that's going to happen. And the way that it's going to work is that they're going to send a lander with where Perseverance will either bring back the cylinders, or there will be a mini rover to pick up the cylinders from Perseverance. I believe that's the most current plan. And the cylinders will be put into the sample return vehicle. And then the sample return vehicle will be thrown up by, I think it's a pneumatic ram, about 20 feet in the air. And there it will turn on its motor and start its ascent. And the reason why this is done is that given the fact that there's not the Martian gravity is 40% that of Earth, and given the fact that if you look at a launch ramp complex in Florida, for example, they always got these big concrete pads, right? So those are very heavy. You can't bring one of those with you to launch a rocket with. So what they're going to do with this one is that they're going to chuck it in the air at a slight angle so that the rocket exhaust does not hit, the lander that you brought there, because after the sample return, the lander is still going to be used as a weather station. It's still going to have other stuff on it that will be used to keep doing science.
Oh, that's great. They've been trying to do that for years, not just blow up and annihilate something after you use it once.
But the
Seriously.
sample return mission that did just finish was not from Mars. It was from the asteroid Bennu.
Yes, that's
And
actually the next thing I
if,
wanna talk about. Continue. Perfect.
well, if you remember, the actual sample retrieval happened last year, and it was pretty exciting at the time because it's the first asteroidal sample we ever get.
Yes.
The return method worked flawlessly, and so did the extraction method. And then what happened is that we were hoping for about 60 to 90 grams of asteroid material. We got 120. So the that method to make a cloud of gas and then scoop it back up and let it grab the dust that it picked up worked very well. Worked a little bit too well, if anything, in so much that some of this very fine dust went into one of the screws that held the canister together. And as a result, they couldn't open the thing without contaminating the sample. So they had to spend about 3 months designing an instrument that would let them open the sample return canister without contaminating it.
Right, in a
They,
non-destructive way.
yeah, now they have
Yes.
done it a couple of weeks ago, actually, I think. Some of the samples have been kept, have been put away in
Right, here's what it looks
metaphorical deep.
like. Here's what the sample looks like. So you can see it in there, and
Yeah,
then they opened it. And so what's the extra weight from? I couldn't really figure it out even though they keep explaining it. What's the extra weight from? The sealed sample was sealed when it was sent back. How did it get heavier?
it didn't. Again, the thing is that they picked up more stuff than they thought.
Oh, so it was just the whole thing got heavier, not
Yeah,
the sample. Oh,
yeah.
okay. So some of the articles I was reading were confused about it too then because it
It's
sounded like
not by a lot, but the thing is that you're way out there. You're past Earth's orbit around the sun, and you want to get back to Earth. Even having a
right.
very tiny discrepancy can throw your math off if you're not aware of it.
Right, but the sealed sample didn't weigh any more than it originally did when it was sealed, but they couldn't measure it. There was something going on where they decided to just stick it into the container quickly instead of measuring it again on the outside, right?
Well, that was done in an inert gas atmosphere, and they wanted
Uh-huh.
to preserve the seal, I think.
Yeah, so talk about that again because that's something really interesting that nobody's talking about. That I got excited about when you first explained it to me because you were saying they created a pressure gradient. They basically created an atmosphere long enough to be
Yeah.
able to scoop up so talk about that. That's really interesting.
Okay, so what happens with this? I'm going to give you an example with foam because it moves at speeds that we're used to. The sample retrieval was actually happened in a fraction of a second, and it
Mm,
was using gas molecules instead of foam,
okay.
and so they had to do it very quickly. Let's say that you've got something that sprays foam, and you've got a dirty floor. You spray the foam on the floor, it picks up whatever dirt and dust is on the floor, and then you use a vacuum cleaner to pick up the foam. Now,
Okay.
why would you? And you will end up with a clean floor. This is actually used as a game mechanic in Deep Rock Galactic. If anyone listening knows what I'm talking about, Rock and Stone. Anyway, what happens is why do you need to go through the foam? You can just use the vacuum cleaner. Yes, if there is an atmosphere to pick up. So what
To
happens
suck it up. Okay.
what yeah, what happened with this thing is that they sprayed out a bunch of gas, which would stick around a little bit because it would immediately start gassing out because this asteroid has practically no gravity, but it would linger around for it doesn't even need to linger around for very long. It would hit the ground, it would bounce back up, and it would bring some of the dust with it. And you just scoop that up in that little temporary cloud of gas that you made.
Ah, okay.
The process is fairly energy intensive, and you can only do that once quickly, but it has the advantage of only needing one moving part.
Okay. And so
That
then
makes
that
it
so
something like
so that came back and they finally got it open and they found basically carbon. What'd
They
they
found some
find?
carbon. They found some organic molecules, but we already knew that those were going to be there because we've seen them on other comets, on other asteroids. And what they're doing right now is that there's some grad students very busily writing papers about what they're finding through the kind of destructive chemical analysis that you cannot do locally. And we're expecting a lot of these papers to come out in the coming months. What's interesting is that the stuff has been shared with multiple nations, and some of it has been sealed again and put it away because the idea is, what if 30 years from now we have better chemical analysis tools and we want to go back and look at this sample to compare with others we've taken since then?
Sure.
This is
That's why
not
you
a new
save all
thing, by the way.
samples.
Yeah, this is not a new thing, by the way. Um, we have been opening, as chemical analysis technology got better, we have been opening old bags of old moon rocks from Apollo
Oh, nice.
throughout these years, because back then they made the same decision. They said, well, okay, we got these things. We don't know if we're going to have enough money to send another lander anytime soon, which turned out to be true, sadly. But we will get better analysis tools. So we're just going to seal most of the moon rocks, give some away to diplomats and stuff, study some of them immediately. And the others were sealed and opened at a distance of, 10, 15 years, because by then we would have better microscopes, would have better spectroscopy equipment, and so on.
Oh, great. Okay. So now that tool that was used, the Osiris, I want to say, dun, 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 it's really cool. It's basically going to keep going. The Osiris. So it was Osiris Rex,
Yeah.
and now they've renamed it, and it's Osiris Apex going on its new mission to Apophis, which turns
Yeah.
out is
So what?
not going to kill us. Take it away, Matteo.
Yeah. So what happens there is that they obviously the sample return system was a one-shot mechanism. They don't have those in a revolver barrel, so they could only do that once. But the rest of the little probe still works, most of it, and it still had some propellant. So they figured, let's get some extra science out of it. This is fairly common when you can get away with it. For example, New Horizon did a flyby of Pluto, but then they used that to swing around, and now it's going to visit a couple of other trans-Neptunian objects in the coming years. But going back to the Osiris Apex, essentially what they did is that they just shut down the stuff that they used for the retrieval and that really clever vacuum cleaner system, and they still have a working probe after that. Now, taking off from a little asteroid like Bennu is very easy because it's tiny. Has almost no gravity. So the little maneuvering engine that Osiris X has was able to just kind of push itself back up. And what they've chosen to visit next is the asteroid Apophis, which I think that you need to educate me here a little bit, because why do people say that it's gonna hit us? Because I've seen that meme, but I'm not familiar with it.
I I don't know, because you made it very clear that we know now it's not going to hit us. But when I was doing my research, even last night, there were and we've known it's not going to hit us for a while now. I mean, at least since last year. And
Yeah.
even videos coming out in the passing weeks. I think they just want hits on YouTube, to be honest.
Okay.
So explain to
Because
us
now
how
I'm
it's
good.
definitely not going to hit us.
Well, since it looked like at some point it did look like, hey, this is gonna pass us very close. It might hit us, and it's pretty big. It's about 1,000 feet in length, right? So that's not enough to, kill the dinosaurs all over again, but it would be enough to do a lot of damage if it did in fact hit. So what they did is that they said, let's pay close attention to it. Let's make sure that there's always something pointed at it. And what they have done over the years is that they were able to look at its orbit very precisely. They could, take a snapshot using a telescope, using a deep space radar, anything like that. And what it allowed them to do was to determine its orbital parameters very precisely. We know how big it is, we know how fast it's going, we know the trajectory that it's on. What we found is that this thing will, in fact, come very close to the Earth. And by very close, I mean 20,000 miles out. But it will then swing past. This is still going to be interesting because it will be very much visible from Earth instruments that are, of course, going to be better than anything we put in space, except possibly the James Webb, which has a different job.
Hmm.
So we will be able to get a look at an asteroid that normally stays further out with Earth-based instruments without having had to go and pick it up. Apophis was actually discovered 20 years ago, and at the time they said there's a 1 to 5% chance this is going to hit, and that was serious enough to keep paying extra attention to it. We have measured it for 20 years at this point because it was discovered in 2004, and we know exactly what it's going to do. And what it's going to do in this case is that nature has decided to give us a pass. There's a cute thing by Terry Pratchett. He used to say, giant asteroids are nature's way of asking, hey guys, how's that space program coming along?
Yeah. So it helped us get our act together in terms of
Yes,
tracking these things and being able to track them. But now that we've tracked it and it's not coming, it seems like people didn't get the memo because it's just it I think, like I said, I think it's you just get more YouTube views talking about comets hitting than talking about them not hitting. But when I found out it wasn't hitting for sure, I wanted to make sure that everybody knew because there's people actually worried about this. And maybe
I
they can
appreciate
know
that. There's
that they don't need to now. They can worry about there's plenty of other things to worry about, and they can go worry about one of those things, not something that we know is not going to happen. So great. So on that happy
Thank you
note,
for doing
Matteo,
that.
yeah, you're welcome. It's one of the things we try to do on this show. It's not usually so cut and dry. It's usually trying to give other sides of things. It's not usually when there's generally a fact that an untruth that is being perpetuated that we can just say not true, but let's do that too. So that's great. Thank you so much. I love putting you on the hot seat here. Thank you for answering all the questions and teaching us all about these historical things that are going on. It's basically just history being made almost every day now when I look up and it's such an exciting time. What a time to be alive, as people joke about.
And that's the thing. You don't need to. People don't need to make up conspiracy theories to feel important. What's going on is already very interesting.
Everything that's really going on, yes, is very interesting. And thank you so much. And we'll have you back in a couple months to let us know about the latest, maybe especially after we find out maybe more exciting stuff from the asteroid sample, which we've been waiting for the asteroid. I've been waiting for the asteroid sample since what, about 2008, I guess, is when we first started talking about it, when NASA was actually taking it seriously. A friend of mine, Bruce Dahmer, had been talking to people about it, and everyone was telling him it was impossible. So he made a animation to just show how it
Yep.
would work. The thing would land, and maybe it's not impossible. And now the rest is history. So remember those
Yeah.
ideas. If no one understands what you're talking about, make an animation. It could certainly help get the point across, and the rest might be history.
I would like to remind you that I actually lost $20 because I bet that they would not be able to get a helicopter on Mars, and well, I lost $20. That's
I
the kind
it
of bet you
did,
want to
but
lose.
I did hear that Ingenuity was its name, and I did hear that Ingenuity did finally fly its last flight because it broke
Yeah.
its little
What happened is
propeller.
that one of the propellers got hit. It still spins, but they determined that it would not be safe to fly it again. So if they wanted to, they could spin it up and just actually crash it because it didn't crash. It did a hard
I,
landing and it hit
I
a
was gonna
little pebble or stone or something.
How would it not be safe? There's nobody inside. Why don't they just keep going until it
Be-
actually crashes?
well, because the thing is that all the other stuff on Ingenuity is still working. The camera is still working. So they are still gonna, while it's still in range of Perseverance, they're still gonna use it to take a couple of extra pictures since it's named the right way.
Oh, in his deathbed, the little ingenuity
I
of
just,
taking pictures and doing stuff to the end. Yeah, but that was
yeah,
really cute. It's a really cute idea, and we didn't talk about that because we didn't have time. But just the way the helicopter worked, the helicopter went out and scoped out places that it thought would be interesting, and to tell the rover, the bigger rover, where to go and get the sample. Right?
yes.
That's
Again,
that's
it
a
was
cool.
mostly an engineering demonstrator, but they also managed to get some useful science out of it.
Awesome. Awesome. Well, thanks so much for coming on the show, and we'll talk to you soon when you come back.
Thank you very
Thank
much.
you. Thanks, everybody. Sweet dreams. We'll see you soon. Bye bye.